Hola, ¿cómo estás? Muy bien, ¿y tú? Alright, so we have our third conic section that we're going to be getting into here, and this is all about circles. Now, we did circles first semester. We talked about the equation of a circle and the parts of the circle, but there's a little bit more to it when we talk about conic sections here, putting it into correct circle format, which we're going to get into, and then just other little types of problems. There is a relationship between the circle and the ellipse, as we'll see here in just a second. But to refresh your memories, the general equation for a circle is x minus h squared plus y minus k squared equals r squared. So this is the equation we talked about first semester, and it's the one we're going to deal with today. This is the general equation for a circle. And as with any equation or formula, we have to talk about what the letters stand for. Remember, in this equation, h and k is the center of the circle. Notice both signs flip, just like in the ellipse. This equation really resembles the ellipse equation, and I'll talk about the relationship between the two in just a second. R in this equation is the radius. Okay. So notice, just like the ellipse equation, you have this whole top part here is exactly what the top part of the ellipse equation is. But a couple main differences. Notice there's no fractions here. There's nothing under the x and the y. And this doesn't equal 1. It equals r squared. So let's talk about the difference between this and the ellipse equation. So in the ellipse equation, you have the quantities over a squared and b squared. Well, what if a and b were the same? I want you to think about that. If I had some equation that was like, x minus 2 squared over 4 plus y plus 1 squared over 4 equals 1. So you might look at this and say, oh, that's an ellipse. And if you go to graph it, look at what happens. You don't need to write this. I just want you to watch and see where I'm getting at here. So if I was looking at this as an ellipse, well, the center would be at 2, negative 1. And then, now, look, we can't distinguish between which one's bigger, which one's smaller, because it doesn't matter. Since they're the same, then that means that you could think of it, either one of them, as a squared or b squared. So a is 2, b is 2. That means from the center, we would go up 2, down 2, left 2, right 2. And then what gets formed, while this looks like the ellipse equation, you actually get a circle. And so a circle is an ellipse, just essentially squished back together so that it's no longer elongated in either direction. And look at this equation now. Think about if you would multiply everything by 4. Times 4 times 4 times 4. Where you would end up. You would get x minus 2 squared plus y plus 1 squared equals 4. And you get right back to what that circle equation is. So the ellipse equation and circle equation are essentially the same thing, but in the circle equation, a and b would essentially be the same. And then you could multiply everything by that value to find r squared. That's the relationship there, in case you were curious, like a cat. All right, let's do some examples. It says, find the center and radius of a circle with the given equation and sketch the graph. So first thing we have to do is put it into the circle form. Anytime we need quantities squared, and we have x squared and an x and a y squared and a y, we're going to have to be completing the square. And so what we are going to be doing is group the x's, they're already grouped, group the y's, they're already grouped, and add the 11 over to the other side. So that's the part we need to do. So we have x squared plus 2x, leave some space, plus y squared plus 4y, leave some space, equals 11. And then your second step would be to factor out any a value. Well, there is no a for either one of those groups. That's nice. So what we need to do now is complete the square. So we're going to take half of the b term in the x group, half of 2, and square it. So we get 1. So we have to add 1 to the other side. And then we have to take half of 4 and square it for the y group. So 4. So add 4 to the other side. And then we factor. Once you create those c values, we factor. So the x group becomes x plus 1 squared plus, factor the y group, y plus 2 squared, and then add all that mess on the right side. So 16 So there's your circle equation. If you know, there's still a fraction on the left or the right side, or what am I trying to get at here? You might look at this and say, well, why do we know we don't want this to equal 1 and divide everything by 16 like we did with the ellipse? Well, if you did that, you would just create a and b values that were basically the same. It's not wrong. I mean, you wouldn't be incorrect to do that. You would get a and b values to be 4, and then you would still graph a circle. So it's not incorrect. But this is nice because we can easily identify r to be 4. So sketch the graph. Well, we know the center is at -1, -2. Just draw your own little graph. And then the radius, since r squared is 16, the radius is 4. That means in every direction go 4. So I'm just going to estimate here. Left 4, down 4, right 4, up 4. Beautiful circle. So pretty. There you are. Alright. So we basically did that first semester. The only thing new here is we're using completing the square to get it into the proper format. 2. Write an equation of the circle. So we want to put it in that form that has a center at 2, -4, and is tangent to the x-axis. Tangent to the x-axis. Now you might see the hard part of this problem is that word tangent and understanding what that means. Now you learned in geometry, you learned about SOHCAHTOA, right, where tangent is opposite over adjacent. This is a different tangent. Some of you might know what the tangent here means. But what it means to be tangent is to only intersect at one point. Like if I had some circle, you don't need to write this, and I draw a line tangent to this circle, I would draw a line, that stinks, that line should be hitting the circle. But that's what it means to be tangent, when you only hit the graph at one point. So it says the circle has center at 2, -4. So we already know that it's going to be x minus 2 squared plus y plus 4 squared. That's just from knowing where the center is. But we need to know r squared, or r, and it says it's tangent to the x-axis. Okay, well, let's draw stuff, and let's see if something good happens. So I'm going to do a little drawing. So I'm going to put the center at 2, -4. Here. There's the center. And it says it's tangent to the x-axis. That means when I draw this circle and it has a center right there, it's only going to hit the x-axis at one point. And so think about this. If I would draw the circle, it's going to do something like this. Dang it. I missed. Try again. Yeah, it's close enough. Right there. So notice that it only hits the x-axis right there at one point. Think about where it's hitting. It's hitting right at 2, 0. So you know where the center is. You know now an endpoint on the circle right there because it's tangent, so it has to hit right there one time. And so the radius then is whatever this distance is. That radius is 4, so r squared then is 16. We can just pop in 16, and we win. So the key new thing of this problem is just understanding that word tangent, knowing that it means to hit a graph only at one point. Alright, on to number 3. Write the equation of the circle if the endpoints of the diameter are -7, 12, and 5, -10. Okay, so there's going to be problem solving in all these. They're not all the same. I mean, they're all different problems. We've got to think. But any information they give you, I would go ahead and plot it. So I'm going to graph 5, -10, and -7, 12. It doesn't have to be good because it doesn't even say graph it. So 5, -10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just for visual purposes. -7, 12. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, it doesn't have to be perfect. You're just kind of getting a visual. And so this right here is a diameter. Okay, that's the diameter. Well, think about what you know about diameters. Think about, in a circle, if this is the diameter, the circle is going to do something like this. Alright? Now, a diameter has to go through the center. And think about where the center is in relationship to the diameter. Because, after all, if we're after the equation of a circle, we need two things. We need to know where the center is, and we need to know where the radius is. Okay. Well, the center is smack dab in the middle of that line. We know a formula to find the middle point of a segment if we know the two endpoints. Midpoint formula to the rescue. Midpoint formula is x1 plus x2 over 2. You're averaging the x's. y1 plus y2 over 2, averaging the y's. So we are going to find the midpoint of the diameter, and that's going to give us the center of the circle. So that's going to be, let's see, the center then is going to be at, let's add the x's, negative 7 plus 5 over 2, comma, 12 minus 10 over 2. So the center then is at negative 1, 1. Center's at negative 1, 1. I am going to delete this so I have more room to write. I am deleting you. I'm talking to myself. Alright. So let's think about what we have here. We know that the equation then is going to be x plus 1 sine flips squared plus y minus 1 squared equals r squared. Now there are two different ways you can get this r squared. It's completely up to you. You have two options here. You could either find the distance or the length of the diameter, distance formula, and divide it by 2. That would give you r. R is half of the diameter. Other option, which I like better, is we actually know points to plug in for x and y. Remember, x and y are points on a graph, and these 2 points they give us here are candidates that we can plug in for x and y. It doesn't matter which one you plug in, but pick one of those 2 points to plug in for x and y. So you do have two options. You could find the length of the diameter using distance formula, and then divide it by 2. That would find r for you. Or plug in one of these 2 points for x and y. I like this option. I'm going to do that. I'm going to pick this point right here, 5, negative 10. So 5 goes in for x, so 5 plus 1 squared plus negative 10 minus 1 squared equals r squared. We solve this. Remember, we're after r squared here. So 6 squared is 36. Negative 11 squared is positive 121. And so we get 157 equals r squared. And since we're after r squared, we found it. We don't need to square root this. So we can go back to the equation right here and pop in 157. There's our equation. So we had to use the midpoint formula to find the center. And then, again, you had two options to find r or r squared. Sound good? You can't respond to me anyway. All right, next. All right. 4. Determine the equation of the form x squared plus y squared plus ax plus by plus c equals 0 for the circle with center at negative 3, 7 and radius 2. All right, what they're asking for here is they just want you to get your circle equation to look like this. They want it in this format. That's all they're saying, is get the circle into that format instead of the typical format you're used to. So it's kind of going in the other direction of completing the square, expanding everything out. So let's take the information we know, the center and radius, and let's write the equation of the circle to start with, the form that we know. So we can write x plus 3 squared plus y minus 7 squared equals r squared, so 4. And now all it's asking us to do is put it in that form that I have circled there. So multiply these things out and just manipulate the equation to put it back into that format. So when you square x plus 3, this is wrong. This is not x squared plus 9. It is not x squared plus 9. We've talked about that a lot throughout the course of the year. So you can either put x plus 3 twice and then FOIL it out, or use the shortcut that I've been trying to hammer into your head this whole year. Square the first, double the product, square the second. For the y group, square the first, double the product, square the last. again. Or you could put it twice and FOIL it out. And now we just need to put it in that format. So let's see. We have x squared plus y squared, because it wants x squared and y squared here and here, plus ax, so let's add the x's together. Well, there's only 6x, so we don't need to add anything. Plus by, so minus 14y, plus c, whatever the constant is. So let's add 9 and 49, so 58, and then subtract this 4 from both sides. We want it to equal 0. So 58 minus 4 is 54. This is just working on your equation manipulation right here. There it is. Alright, last one. Are you ready? Here we go. Sketch the graph of x squared plus y squared plus 6y is greater than 0. So notice all the other ones, there's been equal signs. This has an inequality sign. Think about what we have to do anytime we're graphing with inequalities. What comes to mind? Hopefully what you just said out loud to yourself is shading and dotted and solid lines in graphs, because that is what should be coming to your mind, and I hope you answered and just talked to yourself. Alright. So what we need to do here is first draw the graph, and then we'll deal with the inequality. That just tells you we need to shade and draw a dotted graph instead of a solid. That's all that's doing. But we notice that this is going to be a circle, and we need to be able to recognize these. We have x squared and y squared. They're both squared. There's a plus sign. And I guess one thing I haven't mentioned, but if your coefficients, the numbers in front of the squared terms, are equal, then that's going to be a circle. Like if this was 2x squared and 2y squared, this would be a circle. If it was 8x squared plus 8y squared, it would be a circle. If your coefficients of your squared terms are different, that'll be an ellipse. Alright. Well, what's nice is normally we would group the x's and group the y's. They're already grouped, and this is particularly nice. This confuses people, but this is actually really nice. This means we don't have to complete the square for the x group. You only have to complete the square if there's an x squared and an x term. That's done. Just bring x squared down, you're done with that part. But we do need to complete the square on the y group. So we have plus y squared plus 6y. So we have to create a c value to be able to factor this into a quantity. Half of 6 is 3. 3 squared is 9. So plus 9. Which means we have to add 9 to the other side. And now we factor. Well, the x group's already factored. The y group becomes y plus 3 squared greater than 9. So at this moment in time, pretend like that inequality is an equal sign. And let's go ahead and graph the circle. So the center, since there's no quantity here in the x group, your center's at 0, negative 3. The radius is 3, because 9 is r squared, so the radius is 3. So in every direction, let's go 3. 3. 3. 3. 3. We're going to draw the circle, but we now have to keep in mind that this is an inequality that we are graphing. It's not an equation. So this is where dotted and solid things come into play and shading. Since it's not equal to, we're actually going to draw a dotted circle or a dashed circle. Dash, 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 dash. Right there. And then we have to shade, either outside or inside this circle. And if you had to guess, your guess is probably going to be right, if all of this is greater than, then we are going to shade outside. So all of our solutions for this inequality would be all of the points outside of the circle. There are a lot of points outside of this circle. Right here. These are all the answers. I'm just kidding. You don't need to draw like that, as long as you just shade a little bit out here. I was just having fun. Alright, that is the end. So again, there's nothing extremely new with circles, working on putting it into the circle format, knowing what tangent means, using distance and midpoint formulas, just little things within here that you'll get a little more practice on the homework. So that is conic section number 3, and we will deal with hyperbolas soon. Have a great day. And goodbye. Adios.